Alright, if this thing's working properly, then I'm live streaming this right now on the YouTube app, which is awesome. If you hear a little squeak in my voice, that's because it's cold and I don't like smog and whatever else. I hope everyone had a great break, enjoyed themselves. We're going to start off with Chapter 6. I know we just finished up Chapter 6, Matt. And for all my students who were here through the last bit and did Chapter 6, guess what? You get to do it again, including the homework. The reason why is simple. You're practicing. You would not go to an NFL game and expect them to try a play for the first time ever in the middle of a professional game. Same goes for our math. I want you to get good at it. Run the plays a few times, so to speak. So with that, we're going to start with section 6.1. This is starting quarter 3, and I hope we have a lot of fun. From there, we'll go into 7, and then we're going to go into some finances and things. We'll finish out with some probabilities and geometry, all the fun in the world. Your objectives, chapter 6. I want you to evaluate algebraic expressions in English. If I say x equals 2, I want you to be able to plug in 2 wherever you see x. Figure out what that is. Use mathematical models. That's fancy for do story problems. Yay! Everyone's favorite. Understand the vocabulary of algebraic expressions. Is it a monomial, binomial, trinomial? What's he talking about? Four-term polynomial? And of course, simplify algebraic expressions. Sweet. Any questions before I begin? All right. What was that? No. All right, algebra uses letters called variables such as x and y to represent numbers. Now, if for any reason you have not been attending my class before, you just stumbled upon this, whatever the case may be, down in the folder, it's in the link in one of these links, there's a folder, and there's some notes where we have these defined. So feel free to look at that, because there are certain letters I don't want you to be using. If you ever send me something with E is equal to something, I'm going to get a little annoyed. Okay. We use variables to represent numbers. All we're doing is using them as bookmark variables. They don't have a static value. It changes. It doesn't mean what the value is. It just means it's holding the place in line. An algebraic expression is a combination of variables and numbers using the operations of addition, subtraction, multiplication, or division, as well as powers or roots. Ooh, fun stuff. So here we have x plus 6, x squared minus 6. Hey, that looks familiar. 6x root x plus 7. Each one of these is just an algebraic expression. Has an x in there. I'm sure we all have an x somewhere, you know? It's just the nature of the world. With that in mind, these rules are just applying the things we do in arithmetic all the time to these funky little placeholders to get what we want. All right, the order of operations agreement. Aunt Sally didn't go away. She's back with a vengeance. You must follow order of operations. You always go to the innermost parentheses, the innermost grouping symbol. But Matt, it's those weird square things. They're called brackets, I think, or the squiggly ones, set braces. Or you know those ones that are kind of weird. Whatever it is, however it's grouped, go to the innermost. Don't play around with the edges. Go to the innermost. All right? If it involves a fraction, treat the numerator and the denominator as if they were each closed in parentheses. Numerators are upstairs, denominators are downstairs. They don't play nice together. Put them in those parentheses. You can't have the upstairs people downstairs with the help Yeah, you can't. Have you ever been to a soiree? Do they just allow the help to wander through the party? No. Help must remain downstairs unless they are serving my needs. I actually worked one time. I worked at a resort, and we actually had a customer one day go up to one of the people who was in charge of the lodge and say, I'm having problems with the help. And it was like, okay. So the person in charge of the lodge said, the help has a name. You know, funny people. But think of it. You want to be snooty with algebra. You want to put those numerators, they are grouped. Denominators grouped separate. Can't mix the help and the staff. Otherwise you might get someone saying, the help has a name. Okay. Evaluate all exponential expressions. Remember, parentheses, exponents come next. Do the exponents next, please. Multiplication and divisions as they occur left to right. Let me repeat. Left to right. How do we read in our system? Right. Left to right. If I can't remember, I go left to right. Now, some people might say, Matt, why don't I just multiply and then divide? What do you think my answer would be?
Did your answer be wrong?
My answer would be wrong? But I'm the teacher. I'm never supposed to be wrong. How could you say such a thing? The order of operations agreement. You can get extraneous solutions that way. Because a lot of times people will do multiplication and division as a separate step. But for anyone who may have been here last quarter, or anyone who may have looked at the notes, or anyone who's new here, you'll get sick of me saying this. Division is multiplication by the reciprocal. So you do your multiplication before your multiplication makes no sense to me. Okay. You put gas in the car before you put the gas in the car. What? What? Start the car before you start the car. See, that doesn't make sense. So on it, we're just going to go in order, left to right, because multiplication and division are the same thing. Division is multiplication by the reciprocal. Ooh, that voodoo thinking that I infected everyone with. All right, perform additions and subtractions as they occur, left to right. And we can do that because subtraction is... I'm putting you to sleep. Addition of the opposite. Yeah, thank you. I appreciate that. Subtraction is addition. Otherwise, we couldn't use all the fancy properties because subtraction is not commutative. It is not. But addition is. All right. Order of operations, same as it was last quarter. If I'm going a little fast, feel free to write me an angry email. Evaluate this statement. So here we have evaluate 7 plus 5 times x minus 4 cubed for x equals 6. Now on this is where a lot of people might get a little frustrated with this. They start looking at this and going, what do I do? You're just going to do the Glade model. Plug it in, plug it in. Anyone remember those old commercials? Plug it in, plug it in. I should put a link to that in my YouTube thing. Anyhow, with this, when you plug in something for x, put it in parentheses. Save yourself a lot of heartburn down the road. It's a great habit. Because if I have 5x and I have 6 for x, was it 5 plus 6? Is it 5 times 6? Is it 56? Putting in those parentheses will save me from a lot of heartache. Because here, this is multiplication. So please, as you're plugging things in, get into this habit as, yeah, it may be a little more ink, and yeah, maybe a little more paper. But if you cared about trees, you wouldn't be learning math. I'm sorry, but you're going to kill a few million trees to learn math. If you cared about ink, you wouldn't be learning math. You have to spin the ink in the paper. Get used to it. Buy sustainable recycled products. If that's something, which we do. We're awesome that way. I saw someone roll their eyes loudly at me. Entertainment value. But you can buy recyclable paper or recycled even. With that in mind, and yes, that is a subject that gets entertaining. With that in mind, use parentheses, please. And I'm going to show you something else that throws a few people off. They'll see f of x is equal to. Now on this, we can think of that as y is equal to, or f of whatever this is. Let's say, in this case, we would do f of 6 for this. F of x is equal to 7 plus 5, parentheses, x minus 4, close parentheses, cubed, and we do f of 6 equals. This just means plug in 6 anywhere you see an x. That's all it is. It's function notation. So if you see it with f, g, or h, they're all function notation. It's the same as y is equal to. You give me this x, what is the y? And for anyone who's struggling going, Matt, I don't remember that. Remember that a function is something that has only one answer per point on the domain. In other words, for every x value, there's only one y. Now, it can be the same y over and over again. That's just fine. But I'm not going to see, you know, if I plug in 6, I'm not going to see 28 and 23. Then it's not a function, it's a relation. So something to keep in mind when you see f of x, g of x, or h of x, that's just a fancy way of saying, hey, plug in whatever you're seeing here for x. Make it happier. All right. An equation is formed when an equal sign is placed between two algebraic expressions. And if you recall from chapter 3, an equation, maybe it was 2, no, 3, we did logic. An equation is a statement that is either true or false, but not both simultaneously. So notice that we're kind of expanding that a little. If you put an equal sign, it's going to be true or false. 10 equals 100. True or false? False. 10 equals 10. True. So it's either true or false. And when we're looking at these, we're always looking for where's this true? Because we can find a million places it's false. That's boring. I want to know where it's true. That's where it's interesting. A formula is an equation that uses letters to express a relationship between two or more variables. And this is where people start to get a little frustrated with me. They're like, Matt, why? Why? But a formula is just a nice little thing that helps keep the world organized. Like I might say, you know, pi r squared h is equal to the volume of a cylinder. It's so much nicer to just remember a formula rather than having to figure out what that is. I just plug in whatever you give me for the R and the H. And then I get an answer and I'm happy. They're related this way. There's some relation. That's all the formula means. When you're using a formula, you're just taking advantage of someone else doing the heavy lifting. And with that, I'd like to do a quick side note. Every time you use a formula, you should be writing it down. You will never forget it if you write it down every time you use it. And definitely the first time, if not the first few times, you should write it in a notebook along with a definition over each thing in it. What is this? Why is it there? How is it related to that? If you do this, you suddenly start to understand math. And while some of your peers may look at it and go, I can't figure this out, you're able to explain it because you have made sense of it. I can't imagine, again, why would I go to the NFL? Why would I go to play in a game without trying a play beforehand. I mean, I can't, even in college ball, I can't imagine them doing that. I can't think of a single thing that someone would go without doing the work beforehand, without sharpening those skills. So, some things to keep in mind. Mathematical modeling is the process of finding formulas to describe real-world phenomena. In English, story problems. There's a secret here. All math is story problems. All story problems are math. Excuse me. With that, I guarantee someone's right now going, he just lied, and they can go that far. But let me explain my logic. Physics was born. Astronomy was born. All of these sciences, chemistry, you name it, were born from curiosity to explain the world around us. We've come up with the mathematics as a way of explaining the things we see in the world around us. When we're doing the modeling, we'll oftentimes take and plug all this information in and get something. Now, a lot of people get frustrated when they run into a story problem. If that describes you, hey, do them until you get to know them and you'll stop hating them. It's like the annoying cousin. You get to know them long enough, yeah, sure, they've got their quirks. Yeah, they may scream at the wall every 5 minutes, but hey, it's worth it. It's a hoot, right? With that in mind, as you get to understand from working with them how they interact with the world, you start to understand the reasoning. When you run into a story problem, a lot of times people struggle with them because they have extraneous information. But our world's full of extraneous information. Right now, there are things on this board unrelated to what I'm teaching. Part of mathematical modeling is knowing how to sort what is useful from what is not. All right, so on this, they do the calorie model. And on this, they just plug it in to figure out where they're at. So here you go. They want to know what the designated calories needed are. They give some information, they give a relationship, plug it in, and bam, you have an answer. Now, when we look at a term, each one of these parts is a term. It's its own term, separated by a sign. We like to classify our algebra using these kind of separations. When we start classifying them, we get an idea of what we're dealing with. So on this, you've got terms here, right? 7x minus 9y minus 3. Each one is a term. Now, the coefficient is the number in front of the letter. That's the coefficient. Now, we run into a point where we start looking for a leading coefficient equals to 1. And people get a little freaked out by that because they're like, Matt, what is that? You know, I'm like x squared minus 2x plus 1. And people look at me and they go, what's the leading coefficient? Why are you working and you keep saying that word? Well, there's a coefficient right here. It's just 1 times x squared. That's just a 1. It's leading because this power is the highest power, followed by that, followed by that. So keep that in mind. When you're looking for a leading coefficient, you're looking for it to be ordered by the powers, in order based on what the powers are. Your leading coefficient is just the term, the number, the constant that's in front of your front term. Each of these is a coefficient, 7 and negative 9. Notice we keep the negative with the 9. A lot of people will ask me, Matt, why are you multiplying that by negative 9 instead of doing subtract 9y? Oh, because negative 9 times y will get me where I'm going. Multiplication is a lot more fun to me. A constant, a term that consists of just a number. And we talk about this a little bit in our definitions. And the way I like to reason it is a variable has an unset amount. If I'm walking down the street and I walk up to the first person I see and say, quick, I need X pieces of gum. Help me or I'll die. What do you think their reaction's going to be? Yeah, I would run away too, because clearly this person's insane, right? But if you needed X pieces of gum, you'd get a little frustrated because no one would know what you were talking about. Wait, how much? X. Please help me. Whereas if I was walking down the street, hey, I need 5 pieces of gum, they'd know what I was talking about. A lot of them may tell me to go take a long walk off a short pier or whatever the case may be, but we know what I'm talking about, and that makes it constant. A constant isn't limited in scope. 1 billion is a constant. It is a number. It has a value. It is clearly defined in the number system. E. Ooh, constant. That's why you don't use it as a variable, ever. All right, so now let's talk about like terms. See, there you have 7x and 3x. When we're doing algebra, we like to sort them into the powers. So on this, you'll have your constants. And let's talk about arithmetic real quick. In arithmetic, you have your ones, then you have your tens, hundreds, thousands, so on and so forth, right? So you have your 10 to the zeros, 10 to the ones, 10 squareds, 10 cubes. Now I might get someone who doesn't remember that any real number except for 0 to the 0 power is equal to 1. We go with that definition. And we went through that with our properties of exponents. But that's really just a 1. See, 10 to the 0, 10 to the 1, 10 squared, 10 cubed, 10 to the 4th comes next. In algebra, we do the same kind of thing. Only we do constants. We do x, x squared, x cubed, so on and so forth, as long as you want. And remember, x is just a placeholder. It could be any letter. Any letter I want. Doesn't have to be an x. So with that, when we're sorting these, if I go to the bank and I deposit 5 hundreds, 2 tens, and 5 ones, are they going to say, well, there's 5 100s and 5 ones and put them in the same pile and call it? No. That'd be 1,000. I'd like that very much, thank you. Why? No, they're going to say you had 5 here and 5 here, and we said 2 tens, so 2 there. They're sorting it by how many it is, just the same way we would sort x, constants, x squareds, so on and so forth. You can't put an x and an x squared together. They're not in the same column. They don't belong together. They aren't made for each other. I mean, they may make a beautiful trinomial together, and it may be the best thing ever. But if I'm combining terms, I can't call them the same. They're not. They're different. So with that, we make it a point when we're combining like terms that they have the same power of the variable, and we can mix them together. Notice here, with the ones, we can put constants together all day. What is 10 minus 4? 6. There you go. I just put together 2 constants, and I tricked someone else into doing the work for me. Yay! The world's a happy place. Factors. If you recall, we did a lot of prime factoring, and with that, we were factoring things down into the easiest ways of dealing with them. And I love to talk about running into brick walls. No one wants to run into a brick wall. I don't know why. I have yet to get a student to do it. One of these days I will, and the paperwork will be atrocious. But we prefer to play with the bricks, the prime numbers. We use the fundamental theorem of arithmetic to break them down. In algebra, we can do the same tricks, and we learn a few more. We break things down into their factors, and by doing so, it makes them easier to play with. Factors are just the things that when multiplied together, comes back to where you started from. Factors of 25, 5 times 5. 1 times 25, either one of those will get you to 25. And now, as if you have not heard me say these properties enough, yay, we love properties. We have commutative property of addition and commutative property of multiplication, meaning it doesn't matter which lane I drive in, as long as I get off at the right exit, I'm happy. When I commute to and from work, I hit the freeway. I don't care if I was in the left lane the whole time or the right lane, as long as I get off at the right exit. Same goes for addition or multiplication. I can switch them around all day. Doesn't matter. Isn't that beauty? That always makes me happy because we talk about it a lot. Associative property of addition or multiplication. Again, I group them however I want. Who they hang out with doesn't matter. The whole thing can be grouped any way I want, and I use those left, right, and middle. With that, what about subtraction? It's not associative. It's not commutative. But if we define subtraction as addition of the opposite, ooh, fancy. Same with multiplication, division. Division is multiplication by the reciprocal. Suddenly, hey, I can use these properties. It's beautiful. Distributive property of multiplication states, multiplication distributes across addition or subtraction. Period, the end. Don't make a mistake of trying to do weird stuff. It doesn't make anyone happy. It upsets us. It distributes. If you're not sure, do 5 times 2 plus 3. You should get 25 out. But if you're doing weird stuff, you're not going to get 25. All right, so on these, simplify an algebraic expression. On this, you're just combining them. You're not solving for anything. You're just putting things together. You're going to follow the order of operations. So here, we're going to go on ahead and distribute this through, right? Because we go first off to the parentheses. Very first parentheses. Is there anything I can do? No. I'm looking right here and going, well, but I want to do something right here. It looks like fun. It looks like I could do this, and then I'd stop crying at night because I'd be like, ooh, 3x minus 7, you're my hero. Where have you been all my life? Wait, 3x is different from 7. They're not friends. I can't put those two together, so. Now I'm getting arched eyebrows, which is clearly a sign that I've crossed some lines. So that's okay. We'll cross it again later. So now I look at this and I go, hey, look at that. I can do the multiplication. I get 5 times 3x, 15x. 5 times negative 7 is negative 35. Minus 6x. Ooh. Now I'm going to put things that are alike together using that commutative and associative property. Ooh, happy, happy, happy. 15 minus 6 is equal to 9x. There you go. Bring the 35 along for the ride and you're done. We're just using these properties. That's all we do in here is we use the same properties. If you get sick of hearing about properties in algebra, you're going to have to turn off my YouTube channel and never look at it again. I think that I might put up a banner so it auto-plays every time you log on and it's like, woohoo, distributive property. Who knows? We'll see. The point of the matter is these properties are what allow us to do the algebra and to do some of the most beautiful things in mathematics. Without them, the world wouldn't be nearly as much fun. So with that, I'm open to questions, comments, concerns. I am assigning, and notice I didn't mark it down in here very well. We're doing 1 through 35, nope, 1 through 39 odd, 1 through 33 odd. So we're doing 1 through 33 odd? See, I don't like that. I like 1 through 61 odd. In fact, I say 1 through 63 odd. It'll build our math muscles. What do you think? Okay, just for you, we'll go 1 through 69 odd. No, okay, 1 through 67. I'm just having fun. We really will do 1 through 67 odd. Now on this, if you're having any trouble with this math, feel free to come in. I'm happy to help you. I'm happy to explain it. If you're looking at this going, come in. Send an email. Send a friend. Send a telegram. It doesn't matter. We'll help you. And if you're someone who's been through this already and you know what you're doing, feel free to help others. Helping others is a very strong thing for starting to understand the way things work. Teaching someone else, you will learn more than you ever thought possible. So with that, I'm going to go on ahead and end this here live stream and call it a day. I'm on the wrong thing there. Yes,